All right. So, good morning, good afternoon, good evening, everyone, wherever you're joining us from. And for those of us joining via Twitch or on YouTube, welcome once again to today's class. So, on today's class, we'll be teaching on introduction to cloud deployment, focusing on digital ocean, and we already have our instructor, Dennis Wangi. He's an associate cloud engineer at ProLink, and he'll be taking us on today's class. So yeah, once again, welcome everyone. And for those of us, either you're watching on Twitch or on YouTube, please do well to drop a message on the back end room channel so we'll have more persons joining in. Yeah, so thank you very much everyone for joining. Dennis, welcome once again. So yeah, you can start. Thank you.
Um, thanks, Ella. Thanks for the platform. Dennis, for those who are new, and Dennis Mwangi, Associate Cloud Engineer from Kenya. So today we'll be focusing on cloud deployment, and the major platform we'll be using was DigitalOcean. Yeah, so I guess right to start, Ella.
Yeah, you can start, Dennis.
Okay, thanks. So I believe I'll start from introduction to cloud, what is cloud. Then maybe at the end we'll do a simple deployment of an Django application on the DigitalOcean app. So the site or platform you're using is DigitalOcean. So when you pop up to their page, this is the interface to their platform, of which it is DigitalOcean. So most of us are still new to clouds and maybe computing on the cloud. So a basic introduction on what is cloud and what's cloud computing. So cloud is like, let's say, a chain of more computers that are linked together, forming one broad network of computers. So let's say like a cloud is just like an army of computers. They are invisible and ready to serve you at your demand. So most of the features like on demand and on as in most of the features from the cloud you can upscale, you can downscale at your own convenient time. So you're not aware about it, but all of us reap the benefits of the public cloud. So let's say from maybe our emailing applications such as Gmail, Drive, for those of us who have maybe used the application. So cloud offers most of the benefits. So most of the procrastinators who love to forget about their work. So most of us carry our laptops on vacation where we only use them to get most of our details that are stored on the cloud, let's say from the drive and the emails. So why learn about cloud computing and deployment on the cloud? So in the recent tech fields, most of us are migrating to the cloud. We are moreover moving to the maybe let's say storing our data in the cloud, which is more secure than the normal storing at our places. So let's say most of the biggest tech firms are shifting from on-premise to cloud infrastructures such as the cloud, Kubernetes, where we are storing our data. So the newer tech products are built on top of cloud services. Most of the solutions which could not have been feasible otherwise are now available for enterprise over the cloud. So the other alternative is most of the career opportunities are booming up in this domain. So let's say the associate cloud developers, the DevOps engineers, and more careers that are emerging from the cloud. So what is cloud computing? So in simple terms, we can say cloud computing is the idea of lending out computing services and resources such as databases, software, storage, and networking. Yeah, for over the internet. So for faster innovation, economical solutions in our businesses, and larger scales for the clients on the cloud. So let's differentiate about the modern clouds and the past days infrastructures, on premise infrastructures, yeah, that is. So the traditional IT infrastructures, so let's say it used to use the client-based server architecture to deliver to clients. We used to have a large team to manage the machines. We have the servers that are on premise. These machines used to fail and it needed a lot of maintenance as per se. With regards to manpower, the servers really invested a lot of manpower in them, maintaining them and carrying out routine management practices on the servers. And also, not forgetting, managing the hardwares was a menace. So, what does the modern cloud offer to us? So, using other computing over the cloud, which is the modern cloud computing, using servers that are remotely located. It is a way more than just lending out machines. Let's see how. So most of the applications now are following the new design principles that are flexible enough to roll changes daily. The infrastructure is provided on demand. That is, you don't have to have that infrastructure at your own premise, but you can request it at any point you need to use the infrastructure. Let's say storage. At your organization, maybe you have a storage of maybe a limit of 500 GB, but you need an upscale of, let's say, up to 5 terabytes. It's way more expensive to purchase the 5 terabytes, whereas you can just lend the 5 terabytes from the cloud and deploy your storage facilities on the cloud. So the smaller teams called the DevOps manages the infras and the development of the servers on the cloud. So developers no longer use their machines, rather they use the remote development facilities on the server. So the servers also promote developers rather than purchasing high-end machines with high computing powers. So we have the platform as a service, which helps developers to manage their applications, and also they provide virtual environments for development. So we have the different models for cloud deployment. They are majorly categorized into five, but our major focus will be on these three. So we have the three development models, which are defined by your cloud provider. That is, let's say from Azure cloud providers, we have the DigitalOcean providers. So they all offer these different models for deploying on the cloud. So these three models, you have the cloud, of which our first model is usually the public infrastructure. So the public infrastructure is usually deployed for the cloud, but it's usually less secure, let's say, as compared to the rest of the models, such as the private. So some of the examples for our public models for deploying on the cloud, we have maybe the Gmails that we normally use. The Gmail is a public cloud. We have the Google Drive, that's a public cloud. It is specifically designed for the public, but more of use for the public, but it's less secure, let's say. But at any point you either need an upgrade, it still offers some features of the cloud, such as increase in the size of storage. Yeah. So the other one is the hybrid model. So the hybrid model incorporates both the public models and the private model deployment. So the private is both secure and offers both the benefits of the public and the private clouds for deployment. The other one is the on-premise. On-premise, it's the deployment of resources on premise using virtualization and resource management tools, sometimes called the private cloud. So this private cloud, it is majorly for an institution, let's say a school, an organization, a bank. So those are the ones who use the on-premise. It's majorly for only the employees of the single organization that are using it. Or maybe let's say an association of lawyers, they are the ones who use it. Contrary to the on-premise, we have the community model for clouds. The community models incorporates a certain community. Let's say we have the doctors union. So the doctors union may be using a community model that will only incorporate doctors for a certain region. The cloud service models. So the cloud service models, these are the main models that we use on different services that we need from the cloud. They majorly include the infrastructure as a service, platform as a service, and the software as a service. So let's dig more in the three development models. So our first model is infrastructure as a service. IaaS is the most flexible cloud service right now. Under this model, you're just given bare machines with the most flexibility for you. So the cloud provider, let's say, such as the DigitalOceans, they will take care of your hardware, your network, internet, physical, security, assurance, and all the availability. While you as a user or maybe the developer, you should take care of installing the operating systems, initializing the server environments running, and also monitoring the service of the software. It is more or less like checking the performance, just like maybe you have your own computer. When your processor is so down, you'll definitely realize and maybe carry out a performance measure on the processing capability of your processor. So that's what you need to do and monitor on the infrastructure as a service model. So it is ideally when you need most of the control resources and computationally intensive tasks, like let's say for the video processing, but often it is higher in cost due to the inefficiency of the user. So IaaS offers most of the things. Let's say platform as a service. So this platform as a service, it lies between renting the hardware to renting the complete solution. So here the cloud provides the IaaS as well as takes care of the runtime environment, operating systems, version updates, database patches, network security, business intelligence, health monitoring, etc. So this is majorly for developers or maybe programmers. So platform as a service, it gives you all the computational power that you require. Let's say you need an application to run on that that you don't use it on a daily, but on a certain instance, you need to use that application for your own use. Let's say it's a requirement on while you're deploying an application, or maybe you're building an application. You're building on one framework, but you require a certain framework to continue developing an application that you maybe haven't paid for. So what you'll just do, you'll just rent the platform as a service. You're given the amount of time to use and you pay as you go for the service. So it is mostly ideal for the IT enterprises because it's cheap, agile, and available for low entry barriers. Software as a service. So software as a service, this is what most enterprises create with the cloud. So it's a complete cloud solution which you may like to outsource. So here the cloud takes care of everything. It does the hosting, softwares for you, security and monitoring. So what you focus on is utilizing them to enhance your own product or service. So most of these we have the ERP systems that are hosted from the cloud, mailing services, customer relationship management, etc. So most of these are just the normal softwares that we use on our computers but are hosted on the cloud. So what are the essentials that you require to check before deploying your applications, deploying your storage facilities to the cloud? So do you need the experience with all these services? The answer is no, because all these things are provided by the web service providers and the cloud providers. So although the numbers are huge, you won't need all the services at one time. That's why we came up with cloud deployment models. So you deploy and use whatever you require in your organization or maybe your business. So most of the IT products use common services such as the storage, compute, and we majorly broadly classify the services based on the kind of purpose they solve. So how they solve might be different from one organization, and majorly whatever they solve is just but the same. So let's focus on compute services. So we majorly have the compute services which provide computing resources on the cloud, and some of their services are just like virtual machines. The app services, maybe you're deploying an application to the web servers, containerization, serverless computing. So number one was virtual machines. So the cloud uses the virtualization to allow you use a virtual machine or to host your servers or run a compute process on the cloud. So you may be asking yourself what maybe a virtual machine is. So a virtual machine is just like any other machine, but it can be dynamically allocated or deallocated. So you may use the virtual machines to host your servers. Maybe for the AI engineers, you may use your virtual machines to train your models or provide workspace for your team. So it is a cheaper and more flexible to use compared to physical device. So let's say you are deploying one virtual machine to the web. That virtual machine will be used by more than a single person on an organization. Whereas if you are using a virtual machine deployed on your organization, it will just be a simple device that maybe it's used by one individual on a workstation. But when you deploy the virtual machine, it will be easier to be scaled to be used by more than a single individual at the same time. So that's why we're saying virtual machines are cheaper and more flexible to use compared to our physical devices at our premises. So the cloud providers such as DigitalOcean, we majorly they offer the monitoring, the scaling services to cut down the cost that is incurred with the use of virtual machines. The second one is app services, which is the platform as a service. So a wide range of services lie under this basket. The service they will provide you with entire runtime, operating systems, and the required softwares that you can easily deploy products on. So the platform as a service, app service, is a highly flexible auto-scaling and on-demand, which performs cheaper and more reliable than the said virtual machines. That is, you're just given a platform to operate your operating systems and your applications deployment. So the app services also offers monitoring, analytics, and resource consumption services that are provided also under this service. And majorly this is a concern of our day, deploying our application on the DigitalOcean platform. So containerization, it's also a service. So you might be asking yourself, what is containerization and maybe what it entails. So containerization is just a new update where applications are wrapped in containers to make deployment and development easier. That's services that allow you to ship container to deployment in minutes where they're managed by the cloud. So containerization is basically like wrapping up a certain data. So let's say in maybe the field of data engineering. So we package the data in packets. So those, as in you classify your data in a packet, like let's say a container. You see the way a container holds something. Let's say you have a container for sugar, container for salt. So the same way, the same principle applies. So in an organization, let's say you have a large data set that is similar. It has been grouped and it's similar. So the large data set that is offered in an organization, you package it in a single container, which can be deployed on the web, thus making it accessing the container or the data set easier. So it makes deployment easier as a setup like network and monitoring it because it's managed by the cloud. So anytime you require access to your container, it is just offered instant on the go. So serverless computing. So serverless computing, it's a new concept in the cloud field. So serverless computing is just like saying you running your services on the cloud without physically having the server at your premise. So it can be thought of as a function of running on a managed cloud runtime. So it removes almost all the deployment hassles. Runtime is fully maintained and monitored. You just focus on your business logic. So you won't have the problems we saw behind, that you have to deploy a large crowd, you have to deploy most of the people to be doing the management practices for your servers. You won't have to worry about your server breaking down. So that's why we opting for the serverless computing, which also offers the best security and the availability of the server is guaranteed. So you won't have runtime errors. Maybe the server has broken down. Yeah. So the only limitation are smaller customizing option, time limitation, and the stateful apps that can't be created with this cloud approach. So the other thing that the cloud offers is the storage and the database services. So the storage and the database services, this is just,
Sorry, hello Dennis, can you hear me?
yeah, I can.
Okay, please, what slide are you on now? Because it's still okay, you just moved because it was just on one slide.
Oh, sorry.
Yeah, okay, thank you.
Right now you can see I'm on slide
Yes,
number 22.
yeah, we can see it now.
Oh,
22
okay.
years. Thank you.
Thank you. So the other benefit the cloud offers, or maybe whatever we can outsource from the cloud deployment and the cloud providers, is the storage capabilities. Offers features such as giving you the storage and the access for the storage facilities. You just pay for whatever service you require. So if it's an organization, let's say, as for the example I'd given before, you require an extra storage, or maybe you predict at a certain time you'll have a large data set that your current ability to store won't be enough. So you can just outsource the storage from the digital cloud providers. They will offer you an adequate and the required amount your organization needs to upscale your storage facilities. So this is a continuation on serverless computing. So serverless computing is the fastest way to create APIs and get started in a jiffy. Excuse me, Ella, are you still hearing me?
Yes, I can.
Okay, sure.
I can hear
Thanks.
you.
So there's a continuation on the serverless computing. So we have as I have talked previously, the serverless computing is the fastest way to create APIs and get started in a jiffy. So these APIs, as we work on the APIs as programmers and maybe developers, so at most of the time we require access to the server, we require the push, the other get, we require the get methods that maybe needs an access to the server. Most of us majorly use the local servers. So serverless computing also offers a great and seamless transition for the APIs, where we can create the APIs, push them to the cloud, and use them at any time we require. So serverless name, it comes from the fact that you no longer need servers, you no longer need monitoring, and also the infrastructure that comes in place, maybe for the storage of the server. So scaling for cloud, you can upscale, you can downscale at any time you require. Maybe if you no longer require a service, you just ask your cloud provider to downscale the service. So it's getting popular as it's a no code and low code solutions are adopted by organizations. So in cloud computing, most of the servers, we no longer need to program our servers, we no longer need to carry out management practices on the servers. So what are the serverless functions and why do we offer serverless functions? So serverless functions, it accelerates development by using an event-driven model to trigger your business logic residing as functions in the cloud. So assume your code to be wrapped in small functions that act as HTTP endpoints and IoT triggers. It triggers to messages or an API endpoint for your next serverless backend. So why do we need maybe the serverless function? So it needs a node track to security and code for receiving triggers, etc. It also offers a pay-per execution model costs largely. Yeah, as I've said before, you no longer to pay for a service. You no longer need to pay for a service you don't use. That's the benefit of the cloud. So each function that we are seeing, it has an isolated environment that keeps a line to your microservice architecture. So let's say you don't have to pay for storage infrastructure, whereas you only need a software as a service model. So we no longer need to worry about failures and scaling because the cloud provides us all that. It's at our disposal. So our deployment steps. So after you have opted for deploying your application in the cloud, what are the steps you should follow to connect your application to the cloud? So let's say I'll do some sample project on this. So let's say you have built your application. So the first step is building your project. Whereas let's say it's something, let's say a medical application. So the first step is you'll build your project, ensure it's running. Then after you have built your project, you add Git to your project. After you have added your project, you push it to your GitHub account. Then you create a new static web application from the extension. The next step is to name your application. So this is basically like just connecting your application to your GitHub account. So after you have created a static web app, you just name your application. Then you create a path directory, which has the package.json. sorry. So then you just pick your path to build the folder. So static apps connecting to GitHub, and it keeps track of code changes for continuous deployment. So GitHub provides you the power to continue pushing and committing changes to your codes and adding changes to your application. Sorry. So I believe the next step I can just do a simple deployment for the web app. While you're still practicing for the same deployment on DigitalOcean, I believe their site has numerous examples which you can use to learn as a developer. You can go through their documentation, their API interfaces, and learn more about the DigitalOcean platform. So let me shift to my code editor. Ella, can you see my screen from the code editor?
No, see on the slides. We can't see your code editor.
Oh, a minute. Let me stop the screen. Let me join my code editor. So now you can see my code editor, right?
Yes.
So
So
this
if
is
you just
majorly,
sorry, if you
pardon?
could increase the fonts.
Oh, my font is so small.
Yes.
What about now?
Yeah, I think this is better. No, just one more time. Yes, this is better. Thank you.
Okay. So this is my code editor. I majorly use the Visual Studio Code editors. So the application I was talking about, maybe this is a Django application. I just built a simple Django app for the deployment. So major changes you just for the deployment on the DigitalOcean. So after you have created your application using Python or maybe your preferred language. So most of the changes I'll just do on my settings.py. So from this side, you can only import most of the major things to import are the operating systems, uh, the DJ database URL, which is the Django database. Then on the same on the code editor, so you can come here. You see where there is the secret underscore key is equals the os.get environment. So this is the place where you define where the secret key will be stored, and this secret key you should always keep it private. No one should get your secret key, just like in APIs where you have your own private key. That private key is the only key that you'll use to access your application while deploying on the cloud. So this secret key, so this is just like an instance to declare the secret key, which cannot change at any point, even when you redeploy your application. So this is just a function I created. The get os.get environment is just a function to make the secret key be constant. That is, wherever I'm changing, or maybe redeploying the application, my secret key won't have to be changed. So I just added the os.get environment. Also on the debug, you just change your debug. The debug also focuses back, it traces back to the os.get environment. So the Django secret key, it relates back to the debug inside the parenthesis, and the get random secret key, it traces back the false or true. You set it to false wherever you want it to restrict people changing the secret key. And maybe if you feel like you don't have to keep on changing the secret key, you can just delete this code and just leave it as. So if you feel like you don't have to continue using this code, you can just erase this part. You just erase that part and you let debug equals to true. So at any point, if you redeploy and the secret key is changed, there is no need to keep on changing the debug. So then for the allowed host, this is just a method. Sorry. So the allowed host, this is just a method to give access to whatever IP addresses or maybe the people you'll require to access your application on the web. So let's say it's an organization, you have like 3 computers. So you'll come and just add them here on the allowed host. You'll just add most of the IP addresses. You just pick the IP addresses of the different computers in your organization and you come and add them. So you just fill them inside the quotation marks and separate the IP addresses using a comma, just as I've done. So this is my local host IP address. So after you have inputted your IP address, let's say the 127.0.0.1, that's the IP address for my local machine. So you separate it with a comma and you label it. Whereas maybe you have 10 computers. So computer number 1, maybe you have labeled it James, the second Mary, like that up to the 10th computer. So while you want to maybe erase one computer from accessing the application on the server, you won't have to struggle much on getting the IP addresses and coming back to detect which IP address you need to delete, or maybe you need to update another IP address. So the comma local host, it just enables you to name the IP addresses so that it will be an easier time for you deleting a user. Yeah. So it basically just helps us to carry out the basic application, the basic CRUD application, which is create the read, update, and delete processes. So after you have changed that, you come in. So this is the setting of the development mode, of which it's not a must to add it. But if you maybe require an operation for the development mode, you can just add this piece of code. For me, I just added it to ensure like I have full access of the code that I'm using. So these are majorly these on installed apps, middleware. These will just come when you add the extensions on your applications, or maybe when you install Django. So root URL, this Django underscore app, this comes from when I was creating my application. This was the name I gave to my application. This, let's say, the Django underscore app. So this is the name. This is the name to my application, of which it's the root link to my application. Templates, it basically comes with the application. The WSGI application, it still comes with the application. So it is independent to a single machine. So now this is my database for the application, carrying the authentication, Yeah, so the other thing you'll need to change is the static URL. So basically, the static URL, when you have just deployed your application, it will just be in the form of, let's say, it will just be like static. That's how you'll find it on your application. So, but this is not the best way to use the static URLs. You can also give it a what do you call it? So the other gateway, we can call it as a gateway URL. So you can also give the first URL of which will be identified. But what if this first URL it's not identified when a person accesses it? So we need to give a gateway address. Let's say in IP addressing, we usually have an IP address and the gateway IP address. So if the first IP address is not found, the information will still be transmitted, but using a gateway address. So the same concept is applied here. So we have our static URL, but what if this static URL is not found? Do we have an alternate URL? So that's why we are giving this other static route. So if our first URL is not found, it will access our files from our static route. That's just an alternative route for the URLs. You can have several routes beside static route. You just rename them and give the access or maybe the directories where the static files are located as an alternate. Yeah, this is basically the application on my text editor. So after you have this application on your text editor, this is where you come to your sorry, let me reduce my font, you can see. So this is where you come to your terminal. Maybe use the git bash. So the steps I was showing to push the application on your GitHub account. So you just come and for me, I want to do it because already I've pushed this site to my GitHub account. But you just follow the basic GitHub steps. You initialize the repository, then you add the files to your repository through the git commands. Yeah, and finally you push the application back from your VS Code to come to your GitHub account. So from there, you'll be able to access it and deploy it on the web using the GitHub account. Because when you're logging it or when you're logging in from DigitalOcean, you're basically given some access. So the access controls are like logging in from your GitHub, logging in from your emails. So you can basically create account using your GitHub or maybe your email addresses. So let me now transition to my GitHub account and maybe you see the application where I've pushed it. So my GitHub account is loading. So, okay, here it is. So now this is my GitHub account. This is my GitHub account where I use it to train. So most of the repositories that I've created. So this repository, actually the Django application, I just updated it 2 hours ago. It was when I just pushed it. It's an public repository. So after you have pushed your application back to GitHub, so you'll just come and find it in your repositories. Yeah, on your repository section. And from here, you can now go to the DigitalOcean and deploy your application from their side. So the prerequisites for deploying this application on the DigitalOcean's cloud, the major prerequisite for deploying such an application, you need to have, first of all, you need to have set up your GitHub account. You need to have Python, let's say, from Python 3. You need to install it in your local machine. You need to have a text editor where you'll use to create your application, or maybe you'll use your text editor, such as the VS Code, to create virtual environments that will enable you to deploy your application on the server. That is maybe the DigitalOcean space. So the steps for creating and pushing the application to the DigitalOcean space. So the first step is creating a Python virtual environment for your project. So you just go to your command line, you use the command Python space underscore, no, pardon. So it's Python space dash M virtual environment, and then you label your environment. So let's say you're labeling your environment Django. So you'll just say Python space dash M space venv, which is an abbreviation for virtual environment, then space, you write Django. So the next step after you have created your virtual environment is when you now create your Django project. So this will majorly involve installing the Django framework from the command line. After you have installed, you just set up the debug directives, the way I've shown you how to set the allowed hosts. You set your secret key, the options you need to set a secret key. Yeah, after that, after you have set up your environment, you configure your database, access to your database. Then after you have set an access to your database, the next point will be to review. You first of all need to review your code, ensure that your code is properly working before deploying it to the cloud. So you need to carry out a test. You ensure your code is fully functional, you have debugged it fully. Then now, the ultimate step is pushing it to your GitHub account, using the git init to create a repository. Then after you have created a git init repository, you now add your application using the git add command. And then after you have added your application to your repository, you now commit the application to the GitHub account. So your files will then commit, and now it's now time to push to the cloud. So deploying to the DigitalOcean with an app platform. So let me share my screen now on DigitalOcean. So this is where I'll be using. So after you have fully created your application, so now you come to step number 4, deploying on DigitalOcean. Ella, can you see my screen?
Yes, I can.
Okay, thanks. So this is the last step, of which it involves deploying to the DigitalOcean. So for our instance, we are using an app. So we are using an instance of maybe deploying an application to the DigitalOcean site. So you'll be prompted to, first of all, you just log into their site, which is cloud.digitalocean.com/apps. And then after you have logged into your account on their platform, which is DigitalOcean, you need to click the button that states create an app. So after you create this application,
Hello, Dennis. Can you hear me? Okay. I don't know if it's from my end.
that means when you just come here, you'll be able to log into your GitHub account and you connect your account to allow DigitalOcean to access your repositories, which you'll be using to push to their site. So you can now allow your DigitalOcean provider to access your account. You authorize it, and under your repository. So let's say for my application, the Django app. So under the repository section from your GitHub, you just click on your drop-down menu, you branch your branch name and source directory. So you can now choose whether to enable auto scaling, or maybe you want to do scaling on your own. Then you click next. So DigitalOcean will definitely detect your that is our application. That was the Django application, which is a Python application, and it will automatically populate it as a partial runtime command. So you can click the edit pencil. You can click the edit pencil icon next to the application. Uh, so yeah, so you can just click the edit pencil icon next to the application. You edit the run command section. After you have completed it, you need to reference your project's WSGI file. So for this example, the WSGI file, it should be on your GUnicorn application site. So back then to your VS Code, that's where you'll get this link for worker temp directory. So that's where you'll get that, because you have the WSGI extension installed. So after you have that, you create now an application on their site and deploy it. So basically, these cloud providers, they just offer you a very simple and, let's say, a very simple process. It just dictates, like, it will tell you whatever you need to do and whatever process or instance you need to be performing. And if at all you encounter any problem as a developer, definitely the best part to go for is the referencing and maybe the application's documentation site. So most of our applications, we usually have the developer site where you can always get the API documentations or anything to do with their site. So it basically helps us to do anything on their site and maybe deploy everything that we need to deploy on their sites. So you can just come to the developer option. It will give you an introduction to accessing their APIs, deploying on their site, and all those. Yeah. So the next part will be the next part now. So our last part will be we covered the deployment steps. Now our last part, yeah, question and answer part. So Ella, do you have any question?
Okay, yes, so we have two questions. So I'll just display it on the screen.
Pardon?
We have two questions. I just displayed it on the screen. Can you see it?
Okay, let me check. And the comments.
Yeah, but it's also on the screen. You can see it on your screen.
Oh, after creating a virtual environment, do we need any other thing to use the virtual environment? That's the question.
Yes, that's the question. That's the first question.
Okay, so Elihirim. So after you have created a virtual environment, definitely that's like a Python script that you have created. So for the Python script that you have created, you'll definitely need to enable it to run, like activate the command. So for activating the virtual environment, you'll just need to go to your command line. You just need to go to your command line, you open your command line, you access your file location where you have located your application from the command line. After accessing the application from your command line, you'll just need to give it access. So let's say practical evidence. So you just go to your command line because you'll definitely need to give it access for you to use it. So when you go to your command line, you'll just run the command. That is after you have activated it. Okay, let me just do it practically using my command line. Or majorly for me, I'm using Windows. I'll just use my Windows PowerShell. Let me present on the PowerShell. So I believe you can now see my PowerShell. So I'll just go to my current directory. Sorry, let me use VS Code. A minute. So yes, you'll just come to your PowerShell from the VS Code, which will be easier to access your current directory. So the current directory that I'm in, it is the documents github slash TensorFlow. So that's the file name for my current directory. So when I just come here, I'll just paste the command. I'll just paste the command dot backslash. Sorry, so it's just dot backslash. You run the scripts folder backslash activate. So most of the Windows application, or maybe all the users using Windows, so most of you'll find these this environment, it hasn't been activated for you, the virtual environment. So you'll need to run this script for you to activate the virtual environment. So you'll just write /activate dot PowerShell1 PS1. So when you run this script, I believe you can see it accessing your application. When you run this script, you'll activate the virtual environment for use. I believe I've answered that question. Ella.
Okay, so I just displayed the second question. I don't know if you can
Oh,
see it by the same person, but there's another question. Yeah.
yeah, the second question. He says you have mentioned creating a virtual environment and then loading the Django files next. Is there a step in between these two? So after you have created your virtual environment, I've said then loading the Django files next. Is there the step in between after loading the or creating the virtual environment? The step that you're asking Hirim, it is about importing the importing Django libraries. It's just basically importing Django to your VS Code. That's the step.
Okay, I think that is the last question. And I think they're also requesting if the slides will be made available for them, will be shared also. I think
Uh,
that is possible, right? So I'll reach out to Dennis as regards
yeah,
the material.
I'll share them.
All right. Okay. So thank you so much. I think that is the last question. Thank you so much, Dennis, for today's class. You really did a good explanation, and we were quite clear as regards deploying applications on DigitalOcean. Okay, for everyone on the call, please, if you have more questions or if you want to network or reach out to Dennis, you can reach out to him on LinkedIn. So his handle is being displayed on the screen. So you can follow Dennis Wangi. I don't know if I got, yeah, I think I got the pronunciation right. So please do well to connect with him, and he's very active on LinkedIn. So please do well to connect with him. And if you have more questions, you can ask him on LinkedIn. So yeah, thank you so much, Dennis, for today's class. Thank you so much for being with us today. And also for everyone on the call, thank you so much for joining us. Either you're joining on Twitch or you're joining us on YouTube. And also we'll be having the last class for the backend track today by 8 p.m. West African time. So do well to be here by 8 p.m. for the last class. And also we are having our last Q&A session tomorrow by 9 p.m. West African time on our Discord channel. So please do well to be there. Thank you so much, Dennis, and thank you much everyone for joining today. Yeah, so bye guys. Thank you.
Okay, bye bye.
Bye. Thank you.